Good morning. This discussion is for a project Identify Medicine or Pillow. This pillow identification project is based on deep learning and uses TensorFlow and Keras library. And these are the contact details. WhatsApp number is as shown on the screen, and our email ID bbakTech@gmail.com. Any doubts or if you require any clarification, please contact on this. And today I'm going to discuss about pill identification project. It is related to healthcare industry. So now I would like to say what is pill. Pill means it is like in tablets. Its image will be like this. So this is one pill. You can see this is a pill. And what are the characteristics of this? This has got some shape is a one property, and of course it is having color. So there is a second property, and the third thing is there is something written over it like 500. So this is called imprint. Shape, color and imprint. Among this, in some tablets comes with some lines which can be used for cutting and like this. So see, for example, I'll show you. So this is red color round tablets. Shape is the round, circular, no? And this is capsule. So color and the shape and color, shape and what are other properties you can say, an imprint, something written on that, and then form, whether it is a tablet or a capsule or maybe a oral medicine which uses for syrup. So like this form. And then scoring means what I told you, there are some lines will be drawn on this pill. So these are all the properties based on these things: imprint code, shape, color and the form and screwing. Based on these five attributes, we are going to identify the pill. This pill belongs to which class, means which come for what purpose it is used, means this is which section 500 pill. Looking at the image, we are able to say this pill is which section 500 pill. If this pill is amul, imol, there is a tablet which used for headache and all, imol, and others. So many different tablets are there. By looking at the tablets and grabbing the information, what is written on that, what is the shape and what is the color and what's going, we should able to identify the pill. That is the project we are going to discuss. So description of each properties are shown. You can read those things also. Now comes, based on this, I need to classify the image classification. Means we have a picture or a image of a pill. So we, by looking at the pill, we should identify the class to which pill belongs to. Correct. We should identify the class to which, class in the sense whether it's a section 500 or it is a imol or it is a paracetamol. These are all the classes. It's a paracetamol pill, like this. So this involves supervised learning. This comes under supervised learning. Here sense, before identification, a model is going to identify the class to which image belongs to, means image of a pillow belongs to. So means we should provide the image of the pill, image of the pill or medicine. Image of the medicine is given as input to the model, and model is going to predict the class, means this belongs to imol. This image means this photo of the image belongs, pill belongs to the imol or which section 500 or paracetamol, like that it is going to identify, no? So that identification done by the model, and it takes input as a image of the pill and produce the output is the class name to which that pill belongs to. To do that, Model should be trained before using the model. It's like that. If you train the model to identify the class of a pillow image, if you provide a pillow image, it will identify the class. For that, you need to train the model. To training the model, you need a data set. So here we are using try we are using supervised learning. Supervised in the sense, the data set what we are providing to the model for training is also going to have each data means image of the pill. Maybe we are in this project we are giving 500 images, means 500 images of pill. So each image belongs to which class? Maybe some 10 pill images belongs to which section 500, some 50 images belongs to imol, some 30 images belongs to paracetamol. So like this. So number of images whatever we supply, we should know each image belongs to which class, means category, means classes should be known earlier, means known no data set to which we know the already classification of the image should be provided. So that is trained labeled image data, means model is trained on labeled image data. You should understand this to predict the class of the unseen image. So predicting the unseen image is the finally required. For that we need to train the model. So we train the model with the supervised model where data set with its classes are available. So this can be done by using CNN model. Convolution neural networks are commonly used for image classification as they learn hierarchical features like edge, texture, shapes, enabling accurate object recognition. CNN model enables us to identify the objects accurately. So we are using CNN models. So this CNN models, how they work and all, I am going to explain in the next section. But you should understand what is CNN model. I will explain that. But for implementation wise, for CNN, this TensorFlow has given very good modules for CNN, TensorFlow and Keras models are there. We are using them, but I will explain how this CNN models works. So this is the general diagram of the CNN models. Here what happens? Input in the sense X. It means right now we have 500 images. Each is a pillow image, means 500 pillow images are fed, and each 500 means X is an array of images. And what is Y? Y is also an array, but size is same as X. If there are 500 images, then Y is also 500 size, and each item first item in X, which category it belongs to, which section 500. Second image, second Y is also which section for. Third X image, Y third item, maybe paracetamol. So corresponding, X is 500 images, Y is the 500 500 values for values to which class X belongs to. So this is called for supervised learning data. It means 500 images and their related class will be there in Y. So what happens? X is fed into the layer 1, layer 2, layer 3 like this, and prediction is done. Once the prediction is done, our prediction is compared with the actual classification. Predicted class of a given image compared with the actual class of the particular image to check the loss function. Loss means how much difference or prediction is from the original value, so that we will get the loss score. Loss score means difference between the actual and the prediction by the model. So 500 images and 500 predictions will come as an output, and 500 predictions compared with the 500 real values, and we calculate the loss function, and from that we will get the score. This score is used by the optimizer and it readjusts the layers. This is one cycle. One cycle is 500 images are gone through the layers and predicted, and the last function is evaluated, and the score is considered, and layers are readjusted. Second time, seconds, again 500 images go through the layers, means these layers are already adjusted, and adjusted layers and predicts, and again so this loop continues till this last score should be very less. Last score should be very less, means our predictions for 500 image and actual values of the 500 both should be matched to the maximum level. So when that is achieved, then our training the model is completed. And now layer 1, layer 2, these are all adjusted such that if you give any image, in the sense the image which is not seen, unseen image, because it is working 100% correctly for 500 images, if then unseen image, if you provide as an input, it predicts, and that predicts should be same. So this is the way of implementing CNN models. So especially within KN, how layers are there, I will there you will have many types of layers. First one is rescaling layer. What it does, no, the image, what images what you are giving to layers should have some particular size, means length, width and the length. So if they are varying, they must be scaled to some standard length and width. So that is done by rescaling model, rescaling layer. Rescaling layer say, pass the input again to the convolution model. This convolution model is responsible for extracting the features, as we already discussed, uh, color, shape, these features. What is the shape? So means these features are represented in some numerical values, mathematical way. They are extracted by convolution model, and it extracts many features, but max pooling 2D is there, no, this is another layer. Extracted features may be more than what we wanted only 5 features, we reduce the features, extracted features by convolution model of. So these actually convolution model and max pool layers, these two layers are repeated within the model, and then after that flatten. So predictions means features, extracted features are put one and another, and we will create one scale 0 to 100. So as you see in the picture, you see flat layer, so extracted separately and put in a flatten layer. From this we will get the scale 0 to some 100, and based on the value, so I will explain the technique when there is the after flatter dense layer is the output layer provides each class classification, each where it belongs to, like that. So this is the convolution, the way how convolution model works. This is the flowchart that shows how layered approach and readjusting optimizer and loss function, and this is how this thing, and there is a need, we will explain. I will go to demonstrate the project pill detection application. It's a web-based application. Now for this, what is the data set we used? We have got 500 images. I will show you how the images are organized. Okay, so this is the way of organized. See, say under data directory training purpose we are using 500. So but all 500 images are not in the same folder, we created separate folder, because we are having in our project we are having 8 classes of objects, means pills, 8 classes of pills. This is one class of the fill that marked as 500, you can see that marked as a 500. Similarly, see, this is first class, this is, so there are some images we have kept them in 0, and second class is, see, this is red pill, this is the second class is red pill. So each class we created a separate folder, within that we have placed this. So means, so here there are some 50 images, but here even though it is similar to image of the 500, but here imprint is different, it is of Y type, you should see it. but that is not the case in, see, this is 500 is the imprint. Here imprint is 500, but here imprint is y. So it differs. Even the color is same and the shape is same, but imprint is different. So so it belongs to a different class. So we have around 8 class, and images belongs to 8 classes are put in separately. So totally images in all classes together we have 500 images. All these 500 images we know the class, correct, no? 20 belongs to this, 40 belongs to this. See, all these, how many images are there, you can see. So there are 7 images, 60 items are there. You can see that, you can easily see how many images are, you can see here 60 items. There are 60 items. Pillows, there are 60 pills are there. There are 60 pills are there in folder 3, means in the third category 60 images are there. In second category how many are there, see, this is Weimar. So you can see here, you can see 68 pills are there, so like that. So totally what I am telling, including all 7 categories. See, we have 500, but 500 are divided into 8 groups, means, and kept in separate folder based on to which class it belongs to, based on which class. So like this, input data should be organized in such a way that each class of pill should be put in separate folder like this. So this is the data we are using, means this type of data, organized and labeled data, is required for supervised learning, and our CNN model is a supervised learning model. So you understood the data set. There are 500 images, belongs to 8 categories, and they are kept in 8 different folders, in data folders, use it to train the CNN model. Now I will show you the how the code is there. So we use this one Visual Code Studio for implementing any AI related works. See, this is the data subfolder, you can see. So this is in this train is there. In this there are 7, there are 7 subfolders. So you can see 7 subfolders. See, 01 is belongs to 500. You can see, no, 500. And second one is data set belongs to red tablets. So like this, they are all in the totally all the images together exist in all 8 folders, counts to 500. Understand? So this is another folder. So this is having red color but shape is different, and this is another one. So this, so they are all kept. So these are all the data which is organized and labeled, means this zero, like this labeled data is kept in separate directories to train the model. After keeping this, how the training model is there, I will show you. See, this is the how this, see, directory, train directory, data train. So data train is going to have the, so you can see data train. So this is the data we are using for training purpose. We are creating the, so once, yeah, so this is the, so directory data train which has the label data. As we explained, it is in separate folders. Each class of data is in separate folder, and that is and we are creating the model, sequential model, because layers are sitting one or the other as explained here. So here we are explaining the layer 1, layer 2, sequential layers. So it requires sequential model. Layer 1, layer 2 are, as we have already explained, rescaling is the first thing. input is be rescaled, and convolution 2D model, because we are working on an image, it's a 2D image, so convolution 2D model need to extract the features, and the maximum pooling model reduces the feature. These repeats number of time convolution model and maximum pooling is used within the sequential model depends on the domain. For our domain, two times repeating will be fine, and flatten is the last, means features should be faced one another, and forming the scale, and dense is map the output. This is the thing I will explain when there is a need. So so this is what, see, rescaling, convolution is the first, and maximum pooling, convolution, maximum pooling, and convolution maximum. Three times we are repeating convolution and maximum modeling. After that, dense layer, flatten, and dense layer matched into the number of classes. We have made it as a seven classes. No? It converts the scale into seven layers. uh, 1 to 100 is divided into seven parts to map the output. So this is the sequential model is created, and after that, after creating, we are in epochs. So this 40 epoch means this is the number of times we repeat this. Input means 500 images have gone through these layers how many times till we achieve some good results. So this right now, for in our project, we are repeating it 40 times, so we will get the around 80 to 90% accuracy. So, and we are stopping it. It's left to you, you should check the accuracy and then stop it. That is also allowed. So last, see, this is this, so train, and after training, trained model is saved. It takes a lot of time to train. You may require 10 hours, 20 hours you need to run, depending on the input size of the data. For training we are using, no, instead of 500, if you use 5000 images, it takes a lot of time. 5000, like that, depending on your application, this training will come. We already run this and we trained and saved the model, so that is there. Here you can see trained model is already there here. See, till model H5 is the format in which the model is saved. So when we trained by running this, we model is saved, and this model we are using in our web application. I will start the web application. You can see it, how this works. So so I will, so this is the web application. I am going to run this. uh, um, so web application started. See, web application started, and see, score means this is the 0 to 1 scale, 97% accuracy within that. That what it is trying to say. We are, and you see 8. See, this is the first category, 500 mg white long. Second category is the red tablets. So this is given. So there are 8 categories, and input is done. Input is analyzed and saved in the trained model. In this project we are using it. See, verify. See what we are doing. We are not training. We already trained. For training purpose, we wrote separate project program. See, pill model training. This is the place where we have constructed and saved. See, 40 times you repeated and saved. No, 40 times the loop is repeated and saved it. So this is after saving, we are using that in verify. Verify is again used in the web application. So you can see verify is used. You see, yeah, can layers and sequential plot. So this is the detect flow from image. So this is the file verifying. So I have run this project. I will show you how this works. Yeah, through web browser, running web browser. You can click this, open that web, it started. So this is comes like it's online health checkup and pill detection portal. CC. Some students just I by students, my students, I just give as example. uh, for field detection, click here, and we have done 2 projects in this. One is disease protection, but I will discuss disease protection later. This is for pill detection, so I will click this pill detection. See, this is the one. Choose the image of the pill, which one you wanted to predict. So you can say I want to predict what it is, image 4. Okay, upload it. When you upload it, it replay you back with a class. Uploaded file is image 4, it belongs to read capsule. Similarly, you can upload any uh, see, you upload any, choose the any image which you want. So if you want blue, upload this. See, so upload this. See, blue capsule it is. Uploaded image is this. This is the blue capsule. So like this. Uh, Open it. Choose the any image you can choose. So you can choose this image tablet. See, upload it. See, white round tablets. Yes, on top. So like this with 100% confidence. So it means level of prediction 100%. So like this, any image you upload, it will predict and give the class name. Class name is tablets belongs to that. So that means this is called pillow pill detection. Pill detection. Pill detected. So this is pill detection project, and if you want to do any projects related to pill identification, no, not pill identification, image classification applications using deep learning and tenserflow and Keras library. If you want to use TensorFlow and Keras library for deep learning and image processing applications, anything, you please contact us. We will give you the good solution for implementation. Thank you for hearing this. Please note down our details and contact us. Our details are all on the screen. Thank you very much.